All right, good morning. Today we're going to do the classwork for classwork 5, volume of cylinders. So our prior knowledge, we're going to find the surface area of the cylinder. Let's recall circumference of the circle is 2 pi r. The area of the circle is pi r squared. We know our radius, we know our height, and our formula, recall, for the surface area of a cylinder. The surface area is the area of two circles, so 2 pi r squared, plus the circumference, which is the base or the bottom of our rectangle, times the height. So 2 pi r each. And if I were to label this net over here, the height is 7, and the bottom, the length, is 2 pi r, or 2 pi 4. Radius is 4, radius is 4. So here we go, we just plug in surface area, 2 pi 4 squared, plus 2 pi 4 times 7. Putting that all together, we're going to have a surface area that equals 88 pi, or if you put it into your magic calculator, 276.46 units squared. So that's just a little review on surface area of a cylinder, because today we're going to talk about volume of a cylinder. What do you notice over here on this cylinder? They gave us the height of 3, but what else do you notice that they gave us? So they gave us the diameter. So as opposed to having 1 foot diameter, we're going to have a radius that equals 0.5. All right, so here we go. Volume of a cylinder. This is your formula. Of a cylinder. Area of the circle times the height. Just like the volume for a prism, it's the area of the base times the height. How many of those bases do you have? And so what makes up that? We have a circle. Oh, I know what's going on. I can't put my hand. All right, I got it. All right. We have a circle base with radius equal to 0.5, and we have a height of 3 feet. So here we go. If we were to calculate the volume equals pi r squared h, or volume equals pi 0.5 squared times 3. And when we plug that into our magic calculator, we get volume equals 2.36 feet, and our units for volume cubed. Did I do the right units up here? Yep, I did. Next example is us working backward. So they gave us the volume of a can of paint. They gave us the diameter, and since we know the diameter is 6, we know our radius equals 3, and we need to find the height to the nearest inch. So here we go. If we know that volume equals area of a circle, pi r squared times h, and we can just plug in and solve for h. So let's do that. 282.75 equals pi, not 6 squared, but 3 squared. 3 squared is how much? We could just do that right away. Times 9 times 8. So let's divide by 9 pi. What do you need to remember when you're dividing by this? That you divide by 9 and the pi. You need your parentheses. These cancel out. And my height, if I plug it into my calculator correctly, my height, rounding up to the nearest inch, is 10 inches. All right, so let's practice a couple. Here's a can of Pringles shown. Again, they gave us the diameter, so we want the radius, and our radius is 4. So volume equals pi r squared, 4 squared, times 30 centimeters. Volume equals 1,507.96 centimeters. If they want us to find the area of just the label, then we don't want the 2 circle ends, correct? So basically what they're asking when you want the area of the label, with the area of the rectangle. And the area of the rectangle is the circumference times the height. So the circumference, area of the rectangle, circumference is 2 pi r, 2 pi, radius of 4, and the height is 30. When we plug that in, we should get 753 cubic centimeters, or square centimeters. Here we go. What can hold more pepper, the square prism or the cylinder? So I can tell you right off the bat. Let's analyze this before we do the math and prove it. Here's the square, and here's the circle. They have the same diameter. So what do you think? All right, let's prove it then. All right, volume equals 1 times 1, the area of the base, times the height of 3. So our volume equals 3 cubic inches. Over here, our volume is pi, radius squared. So if it's 1 inch across, it's 0.5. 0.5 squared times our height of 3. And when we plug this into our calculator, we get a volume of 2.37 inches squared. So what's the difference? It's those little corners in our square. So the square wins. All right, we've got a couple problems to try. The hardest part of this is recognizing when they give you the diameter and the radius. So as a habit, I always just, whatever the radius is, I just write it off to the side. Radius equals 5. So volume equals pi 5 squared times 3, volume 235, 62 yards cubed. Over here, radius is 12, volume equals pi 12 squared times a height of 10. Well, 12 times 12, 144 times 10, 1,440. So 1,440 pi, or you can plug it in the calculator, and your volume is 4,523.89 centimeters cubed. We have 2 more here. So area of the base is the trapezoid. So remember, area of a trap is 1/2 base 1 plus base 2 times the height. It's not laying on its trapezoid face. So when you look at it, let's make sure we don't plug in a height of 3.5. Look at the diagram. What would the height of this trapezoid be if it was laying flat on its trapezoid side? I'll give you a second to think about that. Volume, plug in the trapezoid. 1/2, base 1 will go 7, the big one, plus base 2, the little one of 3. The height of the trapezoid is 3.5. If we know the height of the trapezoid is 3.5, what's the height of the prism? Well, if I look at 4, that's not it. That's our slant height. So it must be 6. Plugging into our calculator, volume is 105 yards cubed. Here we have a right triangle prism. We want the area of the base, so volume, area of the base, and that's going to be the triangle, 1/2, 3 times 4. And now we need the height. So we have to decide between whether it's 5 or 9. I'm going to tell you it's 9 because 5 is the hypotenuse of our right triangle. So we're not using that. Plugging into our calculator, volume is 54 kilometers.